Hi guys, today we're gonna learn how to make this effect in Blender Geometry Nodes 5.2 LTS beta. Now let's dive in. We are gonna add geometry node setup to our model that we have made already. We are gonna convert the mesh to an SC free. As you can see, when I decrease the value of the voxel, the resolution is increasing. The threshold should be 0. We are going to first one. We are going to some boolean or make some boolean to secure to part of this model position. We are taking the position node and add a separate x, y, z. Separate the x and y and z. We are going to mix the position with some nodes. When we add a viewer node to view the difference, as you can see, if we not add noise, as you can see, the z component is absolutely flat. When we add noise, it's going to show difference. We're gonna increase a little bit. We plug the output value of the color and to the value of the second value of the multiply node to make some Boolean effect on this model. If you want to increase the resolution of the of this, this part of mesh, you have to set the number of this socket to a tiny value. In this part, I'm going to set the 0.01. After this, um, we are going to solve this. We're going to set smooth normal, the smooth normal of this face, and um, we are going to add a mass node between this z and color ramp to move the z-axis. Add, not the type is not going to be multiply mode. It's going to be add mode because multiply mode multiplies the z-axis. It's going to multiply the value of the z-axis, and it's not going to be our deal in this video. We're going to add. Let's show you. Let me show you how. What I mean. When we add the z-axis is moving forward, up and down, as you can see. When we do this, we are done with this part, and we are going to access to the second part. That is we're going to set the position of this part. This part of mesh along the normal. As you can see, we plug this component, the add and add in this something like reference is a note that allow us when we plug this result output of reference to the opposite position, and when we see this effect is going to happen, that's not correct. Why not correct? Because when we plug this blender, uh, as you know, um, this value is made by the black and white values. Black and white values is a value that mixes red, green, and blue colors together with same values. When we one value of the green, let me read green and red, blue. When we set all the green and red and blue value to the one, all of the value of the colors, if it's same value, not one. If they are the same value and mix them together, this should give us a solid white light. Uh, um, in this part, because the output of the socket, output of this map range is a white and black value, that means is the green and red and blue value is the same one. And uh, Blender set the position of each point of this mesh one value. Blender set the position of each element of each point of this, of this model 1 meter in the y component, 1 meter in the x component, and 1 meter of the z component. As you can see, this is already true. We don't want this. We want to um, we want to set the position of the points to only the z, example for example z component. We're gonna add vector mass node to solve this issue. When we add vector mass is doing some vector effect. What I mean, if we increase the z component, it's going to go up and down because we're going to add the blue color to our output, and blue value is increasing. When it's increasing, the how many to go up and down is changing. Because blue value, let me see, let me show you. Let me show you. Look, when we increase this blue color is increasing. When we multiply, change the type mode to multiply. As you can see, all area is absolutely zero because we are multiplied it's by all of them by zero, and whatever number multiplied by zero is zero. When we increase only the z component, z value, the blue is going to show. When we increase this value and this value, what does this value tell us? I told you if we increase this one and green is, if you see green, the points are going to move in x axis. We absolutely don't want this. We want to the normal. We want to move the points along the normal. We don't want to move in the symbol z and x and y component. We want to move the points along the checkpoint normal. We add some normal node. Let me plug normal into socket. Let me. This can be correct, but it's not effective. Why does it doesn't work? Let me think about it. It's work. Maybe multiply this. As you can see, the effect is done. But the issue is we don't want to. I mean, we don't want to. We don't want to. The position of this part of vertices go along to normal because this part of model, this part of model, the vertices of this part of model, normal is this direction, and it's going to move along this direction. We don't want. We want to. We want to move all of the points along the normal of the outer layer, normal. I mean, this part of normal, not the inside. We are going to add sample near surface. What is the sample near surface? The sample near surface is this one. This one. It's going to take all of the vertices of the input mesh geometry, and when we add a position, position to the sample position, it's find the nearest position to this position. It's find the position of the each vertices of the input mesh, main mesh, and find the nearest position to this position of the main mesh, and give us a value. It's going to be whatever you want. We want to sample the normal of the nearest position. When we socket the normal value, it's going to give us the normal of the main mesh and store it to the nearest point. Because the nearest point is the position, so this value is going to give us the normal of this mesh. And then we plug this into this value. Uh, I'm sorry. As you can see, the effect is correctly done. We are going to, as you can see, the mixing this area is harder. We're going to smooth it by adding a lower attribute. Let me lower this in this one. Oh, that's correct. That's completely correct. We are done this in this part, and that's the setup that we have made. After this part, we are going to smooth out this. My system has crashed because this is going to be our setup. We store the UV by having a surface to same UMAP, and UV is part of mesh. Very clean, very clean. Some issues in this area, but can be solved by the high resolution. Okay, we're done. Look at this. We have we have mixed the glass material and the image texture. We're going to add the UV map that we have been stored and plug it in the vector. And this one is the factor that that tells us this part of the area is whiter and this is black and it's factor. And mix it this to BSDF for this world to get a body factor. It's very beautiful. As you can see, the UV is not changing the material. It's absolutely great. When we off the geonodes, the UV is not going to be changing. Only the geometry is changing. That's great. Thanks for watching this video. See you in the next video.